Today is Sunday, 31st, 2022. So, as expected, my first video didn't get any views or anything, which be expected. The market out there is excessively strong for attention. Regardless, I'm still going to make these videos weekly, if anything, just to capture my own thoughts. And if anyone ever does find the videos, then great. Maybe there might be interest then. So, when that happens, I'll be watching for comments, and if you have any questions or any other feedback, drop it in there. I'll respond to it in the next video. Obviously, pick the most recent video because I won't be checking every single video every single weekend. Just the most latest video is what I'll look at. Anyway, so last week I kind of talked about the idea itself in a really 1,000-foot level and kind of the social impacts of it. This week I wanted to give a little bit more information on the actual design itself, just so the more technical people out there know this is more than just a thought, let's say. So, first thing you want to really understand it, you'd have to have a better idea of how the brain works itself. Now, obviously I'm a programmer, not a medical doctor, but from what I do know, parts of the brain work on different aspects of your consciousness. So, for example, the back of the brain has your visual cortex, where it actually feeds all the, sight information in here and then processes it back there. The upper part, the frontal lobe area, is more for the higher thinking area. Brainstem is more for the motor control, involuntary reactions, some voluntary ones, things along those lines. There's a number of spots out there. You can easily find lots of documentation on this. So the idea behind this application, this design, is a modular approach to kind of mimic that pattern, the way our brain works. Give you an idea, it's so every single module would have a defined role. And each of those modules themselves wouldn't be a very smart AI. It'd be practically one of the more, current AIs as we have out there. Or it might even be traditional classical coding, just standard, normal code. No neural networks involved. But, that's obviously going to be defined based on the best solution and the quickest solution for that particular module and its assigned task. These tasks, the reason why we want to set up this way is because when we want to try to find a better way of doing one of those tasks inside of the actual application, you can easily take that one piece out, test it over in a different area to make sure it's working as intended, or maybe even update it and correct it, give it, a better, a more, thorough test without having to deal with all the extra different pieces inside the model, inside the actual application. In this way, if we find a better mousetrap for a particular part of the AI's model or AI's application, then we can swap it in for the new piece. Assuming they still adhere to all the interfaces and such. So now, obviously, first version thing would not be a hot swap, so it couldn't be doing it at runtime. You have to obviously shut the thing down, put in the new piece, turn back on, make sure it still works, test it, and so forth. Because obviously, with something this big, you'd have to have a lot of testing, a lot of QA, and along those lines. Otherwise, it's just asking for disaster. In many ways, actually. Now, let me give you an idea of what one of these modules would be. When part of the way an AI would have to work in any scenario, at least to interact with us in the real world, it has to get data. It has to be able to evaluate that data. In this case, there would be a module to input that data, whether it be from a video source, it could be from a thermal camera, it could be maybe sensors on a machine, it could be any number of things. Basically, any kind of data that can come in and then be able to feed into the AI's application itself, the structure. that would be one module just to get all those inputs and to organize them and get them into the system without any collisions or problems, and to make sure they're all in a correct format for it for the rest of the application to use. Another module that would be right after that would obviously be the one that actually takes those inputs and those data feeds and turns them into a virtual space for the rest of the modules to look at and to interact with. This virtual space would be, effectively the same thing as us building a video game engine and us being able to see through a monitor in that case. The only difference is obviously it's not so much graphical and it's more positional and 3D modeling and such. But I mean, this is all stuff we've done before, so this is not new. This is we could really probably pick up a lot of code off the shelf to make these modules happen. And there's actually a reason why I want to make this a modular system, because for the stuff that we already know how to do or have tools to do these things like facial recognition, 3D modeling, image processing, those things, we don't need to recreate the wheel in those scenarios. We just say, okay, this module needs to do X, Y, and Z. So let's go get this tool that already exists and make it do X, Y, and Z and see if it works. And if it's not fast enough, then at that point, we'd reconsider to implementing our own version of it. But in all honesty, getting it to work in the first place to start just as a proof of concept would be our first goal anyway. So getting something off the shelf that kind of works maybe 80% of what we need should be enough to be at least understand that it's doing what it's doing. So now, one of the modules I know that is not so much out there would be something I would call the long-term memory module. This kind of semi-reflects the way we store our memories as concepts in our heads. At least this is the way I think. I don't know if other people, I can't say to other people, but when I think about something, I might have words that represent that to others and how I communicate to others. But inside my head, I have a visual representation of pretty much everything I know. Or even conceptually as an idea. Each of these ideas obviously compound on each other and so forth and so forth and so forth. But the idea here is that there would be a module that would literally monitor that virtual reality I was just talking about inside of the application, which would then take each of those bits and pieces and categorize them effectively. We have AIs that kind of do something similar to this already, but instead of kind of an unsupervised learning type of situation where it's just observing the world and trying to categorize things the way we do, trying to find for example, if I took I have a pocket knife here. If I took this and dropped it, it might see that when I let go of this, it fell down. That action of letting go of it and it falling, it will record and say, okay, that was one event of that. And then let's say I do it again, like over here. Or it might see that event too and then think, okay, these two events are very similar. Let's categorize them together and then take out all the extra noise that was not part of it. So in that case, the position of where my hand was and the position of where the pocket knife was and how far it fell were different, different, but the actual act of it falling was not. And so it would find those likenesses and then categorize those as a higher subset of those events. And the effective goal of this would be that you'd have a very excessively complex tree of actions and objects and effectively concepts building as it's viewing the world and observing reality. At that point, we as humans would then go to that AI, see those events, and it would be able to show us in some way, through a virtual reality of its own that it can mimic, kind of like an imagination, kind of like a virtual space it can build for us to look at them, and then we can give them proper nouns and verbs for those concepts. This alone would help teach it, not by giving a whole bunch of samples, by letting it find the actual similarities of actions and objects inside of reality, and then we give it a name. Do we need to name everything? No, we just need to name some of it, and then its own hierarchy will then be able to relate each piece to a new event. So if it sees a new event, it kind of looks kind of like this other concept it knows. Then it could say, okay, this thing kind of looks like a car with a certain percentage rating, because it has obviously a list of parameters that meet that criteria. And if it meets that criteria, then it could say, hey, I think it's a car, or it looks like a car. But the idea here is that we currently do that with training as it is, but we only train it on one or two things, like an animal or a cat. We say this is what we want to train you on. We give a whole bunch of training material. This kind of takes in the opposite direction. This says, just look at reality, and then we'll give you names for things when you identify them in your own way. And this level of conceptual learning is not currently there that I've found. And this is something I'd want to build. And this actually be the first step of this AI platform. That'd be the first big milestone, is being able to get that up and operational. But the next step would be the control problem. And that's a big one, to put it bluntly. However, I do have a solution for it. But let's save that for next week. So, as before, if you want to see more of these videos, just like, subscribe. I'm probably just going to keep up with just these normal weekly vlogs until something changes, or I find another way to produce this application. Till then, stay safe out there. See you next week.